Hello everyone. Today we will be learning differential encoding and decoding. Differential encoding is one of the encoding technique used in communication systems. In differential encoding we are using XNOR operation. Let us know the XNOR operation. Exclusive NOR it is. To input XNOR gate, this is the symbol. AB is the input and A XNOR B is the output. Let us see the truth table for XNOR operation. Input A and B, output A XNOR B. A XNOR B, what is the equation? A into B plus A complement dot B complement. For AB input 0, 0, 0, 1, 1, 0, 1, 1, what is the output? So AB is 0, 0, you substitute in this equation so that we will get 1. How? A is 0, B is 0. 0 into 0 is 0. A is 0, 0 complement is 1, B is 0, 0 complement is 1. So 1 into 1 is 1, 1 plus 0 is 1. Similarly, other inputs for 0, 1, 1, 0, 1, 1, you can substitute in this equation and we can get this truth table. One more simple way to remember XNOR operation is when inputs are same, output is 1. When input differs, output is 0. See 0 and 1, input differs, output is 0, 1, 0, input differs, so output is 0. 1 and 1, inputs are same, output is 1. 0, 0, inputs are same, output is 1. Hope this is clear. Very simple way you can remember XNOR operation truth table. That is when inputs are same, output is 1. When input differs, output is 0. Now let us see the differential encoding and decoding with one example. So here one binary data I have taken example. Then let us see how we can differentially encode and decode the data. So here original binary data initially I have taken 0, 1, 1, 0, 1, 0, 0, 1. So this is the original binary data. Now we have to do the differential encoding we have to do for the given data. Differential encoding data, initially we have to assume one reference bit. The reference bit we can assume either 0 or 1. Here I have taken reference bit 1. So with reference bit we have to perform XNOR operation for the binary input. Now one XNOR operation with 0. One XNOR of 0 is what? 0 because differ in input. Next 0 XNOR with 1 is 0. 0 XNOR with 1 is 0. 0, 0 XNOR is 1 because inputs are same. 1 XNOR with 1 is 1. 1 XNOR with 0 is 0. 0 XNOR with 0 is 1. 1 XNOR with 1 is 1. I hope this is clear. For differentially encoding data, initially we have to take one reference bit. With the reference bit, we have to XNOR with the input. So we should start doing like this so that we will get the differentially encoded data. So this is differentially encoded data. Now we have to decode the data. To decode the data, first we have to, for each bit we have to assign the transmitted phase. We need to transmit the phase for each differential encoded data. For 1, the transmitted phase is 0. For 0, transmitted phase is pi. Okay. So for 1, 0 is the transmitted phase. For 0 pi, transmitted phase, 0 pi, then 1, 0, 1, 0, 0 it is pi, for 1 it is 0, for 1 it is 0. Hope this is clear. What transmitted phase we are assigning? If it is 1, if it is bit 1, 0 phase. If it is bit 0, then transmitted phase is pi. Okay, now let us see how to decode the data. So decoded data is, we are going to decode this. So here, when there is a difference in phase, decoded data will be 0. When there is a same in phase, decoded data is 1. Here we can see transmitted phase 0 and pi there is a differ in phase. So the decoded data is what? It is 0. Pi and pi, the phase is same, decoded data is 1. Pi and pi, same phase 1. Difference in phase 0. Same in phase, it is 1. Difference in phase 0. Difference in phase 0. Same in phase, it is 1. So when you compare decoded data with the original data, it is same. 0, 1, 1, 0, 1, 0, 0, 1. So this decoded data is same as original data. So differential encoding and decoding we have done using reference bit 1. Now let us differentially encode the data by using reference bit 0. So here, so same original binary data I have taken. Okay, now with the reference bit, how encoding and decoding we can do, let us see. Original binary data 0, 1, 1, 0, 1, 0, 0, 1. Now differentially encoded data, to differentially encode we have taken reference bit as 0. Now 0 XNOR with 0. See, differentially encoded we are using XNOR operation to differentially encode the data. So 0 XNOR with 0 is what? It is 1. 1 XNOR with 1, 1. 1 XNOR 1. 1 0 0 0 1 0 0 0 1 1 0 0 0 1 0. You should remember the XNOR operation. Okay. So now differentially encoded data we have done assuming reference bit as a 0. Now we have to assign the transmitted phase for each bit. If it is 0, what is the transmitted phase? It is pi. If it is 1, bit 1, transmitted phase is 0. Bit 1, 0. Bit 1, 0. 0 it is pi, 0 it is pi. For bit 1 it is 0. For bit 0 it is transmitted phase is pi. 0 it is pi. Now how to do the decoded data? We have to see the difference in the phase. If there is a difference in phase, decoded data is 0. If same in phase, decoded data is 1. So for this bit, we need to decode this bit. So with compare with previous this phase, pi 0, there is a difference in phase. So decoded data is 0. 0, 0, same phase 1. 0, 0, same phase 1. Pi 0, difference in phase 0. Pi and pi same phase. So it is bit 1. Decoded bit is 1. 0 and pi difference in phase. Decoded bit is 0. Difference in phase. Decoded bit is 0. Same phase. Decoded bit is 1. When you compare original binary data with the decoded data, it is same. You can check. It is same. See, when we differentially encode the data, whether you assume reference bit 0 or 1, when you encode the decoded data, you will get the same. With this example, I think this is clear to you people. Now let us take one example and write differentially encoded and decoded data. Okay, here original binary data I have taken this. Now any bit reference bit you can take. I will take reference bit as 1. So 1 differentially encoding, we are going to do the differentially encoding, that is using XNOR operation. 1 XNOR with 1 is what? 1. 1 XNOR with 0, 0. 0, 0 XNOR is 1. 1, 1 XNOR is 1. 1, 0 XNOR is 0. 0, 1, 0. 0, 0 it is 1, and 1 XNOR with 1 is, it is 1. So differentially encoding we have done. Now let us assume, let us assign the transmitted phase. For bit 1, transmitted phase is 0. For bit 1, transmitted phase is 0. For bit 0, it is pi. For 1, 0. For 1, 0, transmitted phase. For 0, it is pi. For 0, it is pi. For 1, it is 0. For 1, it is 0. Now let us decode the data. So this data we have to decode. So compare the phase with the previous one. 0, 0, same phase. It is, if it is same phase, then it is 1. Pi, compare with the phase. Difference in phase. So it is 0. 0 and pi, difference in phase, it is 0. 0 with 0 same phase, so it is 1. Pi and 0 difference in phase, decoded data is what? It is 0. Pi and pi same phase, so decoded data is 1. 0 and pi difference in phase, decoded data is what? 0. 0 and 0 same phase, decoded data is 1. So you can see that we have assumed reference bit 1 and differentially encoded, and when we do the decoded, when we decode the data, you can see input and output both are same input. So virginal data we have differentially encoded and we have decoded. So this decoded data is same as the virginal binary data. You can try assuming 0 reference bit. This is the reference bit. Using you can check assume 0 reference bit and differentially encode and decode, and you can check. Hope this is clear to you people. Thank you.